Hi guys, today we'll be presenting our project on hospital readmission trends and predictive factors using the TestClaims 10K dataset. Our goal here was to analyze multi-year claims data and develop models that are accurately predicting which patients are at the highest risk of 30-day readmission. This project was completed for George Mason's HAP 780 course, where we were able to combine SQL-based data engineering with machine learning modeling, such as Weka. So, a little bit of background about the topic that we chose. Hospital readmissions are a major concern for both quality and costs. Nearly about 20% of adults return to the hospital within about 30 days, which signals gaps in healthcare and follow-ups. We were able to use the dataset Test Claims 10K, which was provided by our class, where we had access to multi-year longitudinal claims data that allowed us to track hospitalizations across year one to year three. So we wanted to go ahead and focus on research on these three main points that we wanted to address. Can we accurately predict 30-day readmissions using demographic, clinical, and utilization variables? Which variables are the strongest predictors, for example, prior admissions or comorbidities? And finally, which machine learning model performance performs the best? Is it either logistic regression or random forest? Okay, so the main problem is highly relevant because um, CMS imposes financial penalties on hospitals with excessive readmissions. Accurate prediction allows health systems to intervene early for high-risk patients, improving continuity of care and reducing costs. And our objectives here were to make sure that we build proper models so that we're able to show the levels of data from test claims. Overall, we just wanted to use our data to go ahead and compare the performances of two different logistical regression models and using different models in Weka. Come up with key predictors such as readmission rates, prior admissions, length of stays, and just overall healthcare utilization patterns. And we just want to make sure we can determine which model yields the highest predictive accuracy and best supports our risk efforts. So first, what we have to do is we have to create a final admissions table, which we will be using in order to run the different Weka models. And the data set used in the study is test claims 10K. Um, we are able to have a data set of about 10,000 patients, all pre-processing and feature generations, which were all done using Postgres. We extracted all inpatient claims, identified the earliest year one hospitalizations for each patient as the index admission, and then scanned forward to see if they had any inpatient claims within 30 days. These became our readmission labels. So our dependent variable can be identified as binary, whether or not a patient was readmitted within 30 days. We created this directly in SQL by comparing index claim dates with subsequent inpatient claims. So one would equal patient had an inpatient hospitalization within 30 days, and zero would equal no readmission within 30 days. And the independent variable included demographics such as age, sex, clinical indicators like comorbidity counts, and utilization measures such as ED visits and outpatient visits. Some of the variables here, LOS stands for length of stay. Year one was the outpatient visits. Year one also had ED visits. We just wanted to make sure we could use as many variables as possible that our data set gave for us, and just making sure we looked at the different columns so that we were aware of the different independent variables. Here we have our SQL analysis. We basically identify Inpatient admissions, we define index days, calculate the 30-day readmissions. We were able to join multiple tables, such as the claims diagnosis table and member demographics, which really helped us get the sex and the age, which were important factors. And finally, we were able to export the fully joined table as a CSV for WECA modeling. Without joining the tables, we wouldn't have a full CSV that was made. Okay, and then for the WECA portion, we imported the SQL generated data set into the WECA Explorer after converting categorical variables, handling missing values, and removing identifiers. We trained two models. We went ahead and went with a logistic regression model and the random forest model. The logistic regression was our baseline, useful for interpretability, and our random forest was a more complex nonlinear model capable of capturing variable interactions. These models allowed us to compare explainability versus predictability accuracy. So our SQL work confirmed the structure of the dataset and prepared a clean analytical file. We established index admissions, generated predictors, and we were able to validate the distribution of variables. So our key predictors that we were able to examine are within this list and can also be seen when running the CSV file on Postgres. These predictors help quantify patient severity, health complexity, and prior utilization, which are very strong determinants of readmission risks at hospitals. And these are just some SQL codes that you can run if you want to find total patients and readmission rates or prior utilization comparisons of comparing the readmitted patients versus the not readmitted. Um, some of these findings were very important when calculating the numbers and supported our decision to include utilization as a core predictor. We were able to establish that older patients have a higher 30-day readmission rate compared to others. Patients over 65 have the highest readmission rate, which aligns with clinical expectations. Younger patients had significantly lower rates, reinforcing that age is a very important predictor. So over here, we were able to show our WECA modeling approach. We created the final data set by removing identifiers, converting categorical features to nominal, and inputting missing values. Our target variable was readmit 30. The setup ensured compatibility and consistency across algorithms. Our results overall showed that random forest significantly outperformed logistic regression with an accuracy of about 97.5%, recall of 99.1%, and ROC AUC of 0.998. It also missed far few readmissions, only 2 versus 10 for logistic regression. This makes random forest the preferred model for real-world deployment. So we can be able to see here our comparison of using the two models and the numbers that we got for each. So in conclusion, we successfully created a predictive modeling pipeline. We engineered features using SQL, cleaned and modeled the dataset in Weka, and evaluated two machine learning algorithms. Random Forest demonstrated excellent predictive performance, particularly in identifying true readmissions. This project highlights the power of combining claims data with predictive analytics to support hospital quality and improvement. And by using these predictor values and creating further models, we can go ahead and help with the readmission rates that we see these days in hospitals. So for some future work moving forward, we plan to expand the model by adding more predictors such as social determinants of health and medication patterns. By incorporating more years of data may also improve model stability. We'd also like to explore advanced algorithms like XGBoost or gradient boosting and evaluate fairness across demographic groups. Ultimately, the goal would be to deploy this model and to create a dashboard for real-time monitoring of readmission risks and being able to work with more hospital groups. Here's all our references, and we hope you enjoyed our project. And please comment down below any suggestions that we could have done to improve this. Thank you.